Bismillahirrahmanirrahim. Today we will start the lecture 5 of our course Digital Electronics, and our today's topic is logic gates. In this we will study the gates AND, OR, NOT, NAND, NOR, XOR and XNOR. Okay, we will start our topic with the gate that is AND. The gate AND says that we will multiply our two numbers. Like our first we will see its symbol. These are our inputs A, B, and the final output we have is Y, which is equal to A dot B. Simple dot multiplication. So A, B, and the result is Y. We have 0, 0, 0, 1, 1, 0, 1, 1. So by doing the simple multiplication, we will have 0, 0, 0, 0, 1 equal to 0, 1, 0, 0, 1, 1, 1. So we see that we have the final result y equal to 1 when our both inputs are 1. So this is its, we can say the diagram or the symbol we have, that is like simple D we have to write. Okay. So the next gate is OR, which says the addition process. Its diagram is like this. The arrow, two inputs A, B, the output is Y, which says A plus B, the addition of both inputs. So A, B and final is Y. 0, 0, 0, 1, 1, 0, 1, 1. So by doing the simple addition, 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. It says whenever our both inputs are 0, the final result is 0. And whenever any of our input is 1, the output will be 1. Okay, the next gate is NOT, which is basically the conversion. Its symbol is like a simple triangle and the NOT gate. It makes it, sorry, it will not go inside. Sorry. Okay, I will draw it again. Okay, like this. This is basically the symbol of conversion. Input is A, output is Y. Input says 0 or 1. The final result we will have is its opposite, 1, 0. It will basically just convert our input. If it's 0, it will be 1. If it's 1, it will be 0. So the next we have is the NAND gate, which says, okay, we will draw it here. NAND is basically, it's the opposite of our AND gate. We will have the NOT with AND, and its symbol will be, these are our inputs A, B. Like this we have the AND. We will draw its opposite, this, and the NOT before the output. So this is Y. We can draw it simply as A, B, the output Y, simple AND gate, and the final Y naught. B, Y and Y naught, 0, 0, 0, 1, 1, 0, 1, 1. Simple the results of the AND gate. This is 0, 0, 0, 1. When both inputs are 1, then we have the one simple multiplication of A dot B. Now we will do its conversion. If it's 0, it will be 1, 0 will be 1, 0 will be 1, and 1 will be 0. This is our NAND gate. The next gate we have is, okay, the next gate we have is NOR, which says the opposite of OR. Like the answers of OR, we will convert it, we will make the Y prime. Okay, its symbol is simply OR gate and the NOT before the output. A, B, Y prime. A, B, Y, simply OR gate, and then its conversion that says y prime 0 0 0 1 1 0 1 1. We will apply this 0 1 1 1. Like whenever any of the input is 1, we will have 1 in the output. As we have the NOR gate, this is our OR gate, and now we will apply the NOT on it. This is our NOT, and the y prime, the opposite of the final answer, 1 0 0 0. This is our NOR gate. Now we have the XNOR and XOR gate. We will do it on the next page. Okay, the next gate is XOR, which says basically its symbol or its diagram is like this: output, two inputs. There we have the another line like this. Okay, I will draw it again. Inputs, this, and then this. Okay, the output and the two inputs A and B. Forget it. Okay, A, B, the final result is Y. 0 0 0 1 1 0 1 1. And now for this we have that whenever we have different numbers like 0 1 1 0, we will have the output 1 1 and 1, and the same number will give the output 0. We can write it as y equal to A XOR B. This is XOR. Okay. So the next gate we have is XNOR, which says its symbol is this. Not, and then this. Okay, as we have XOR, now XNOR. Okay, it says that input A, B, and the final output Y, A, B, and Y. 0 0 0 1 1 0 1 1. The output basically says that whenever we have the same inputs, the output will be 1. The opposite of this, XOR's opposite. Okay, this says like 0 0, we have the same numbers, we have 1 1 1, same, we have the output 1, and for the opposite we have 0, the opposite of XOR. Okay, this is XNOR gate. So these are our logic gates which we will use in the digital electronics course.